Okay, so I'm going to do a video that walks you through the Chapter 1 review. Now, in class, we talked about it some, but this is like a comprehensive, complete video going through the review. You don't have to watch the whole video. For instance, we're going to start with number 1. If you're not stuck on number 1, then skip. You can, I'm just doing this for your information. So, Chapter 1 review. We talked a lot about vocab. We kind of set the stage with some vocab that we're going to use all semester long, and you need to be familiar with it. So make sure you know the vocab words, know what a population is, know what a sample is, know the difference between the two branches of statistics. Make sure you know your vocab. Vocab will be very important throughout the course of stats. I give you some other notes here. I'll tell you that you need to be able to draw a dot plot or construct a dot plot, a comparative dot plot, bar chart, frequency distribution, and relative frequency distribution when you're given a data set, and then be prepared to analyze the data set and summarize the information from the graph to make inferences about the data set. Now, a lot of that stuff we're going to cover here in this review. But if there's something that we didn't, you may want to go back and look at your notes to brush up on it. It is something you need to know. Okay, so number 1. In a psychological study of distance perception, introductory psychology class volunteers were given 5, 10, or 15 extra credit points, depending on their level of participation in the experiment. They walked along paths laid out along hallways in the psychology building and were asked to judge the distance they had walked. Each path was between 100 and 200 feet in length and contained from 2 to 7 90-degree turns. The investigators also kept track of class standing, meaning were they freshman, sophomore, junior, or senior. For each of the variables in the study, determine whether it's categorical or numerical. So that's our first top. That's our first thing we have to do. We have to determine, is it categorical or numerical? Categorical or numerical? For each numerical variable, we have to determine whether it's discrete or continuous. So if we say numerical, we got to do one more step. Okay, A, the true length of the path. Well, it said the distance was between 100 and 200 feet. It didn't say either or. It just said the distance was between 100 and 200 feet. It could be 157.69 feet. So that's going to definitely be numerical. But in particular, it's going to be numerical continuous because you can have all those decimals. It doesn't have to be exactly 106 feet. It could be 106.75. Okay. B, the amount of credit given to the volunteers. Well, let's see. It says they were given 5, 10, or 15 extra credit points depending on their level of participation. That would be categorical. Depending on how much they participated, depends on how much they get. 5, 10, or 15 points. So I'm just going to kind of add that. You don't have to add anything. It's extra information. But just to illustrate, there's 3 categories. Five, 10, and 15. Okay, the length of the path as judged by the students. Again, we're still talking about a length. Length is continuous. Unless told otherwise, length is continuous. And of course, that means it's numerical. So it's a numerical variable that is continuous. The number of 90-degree turns. Well, can you have half of a 90-degree turn? No. It says there's anywhere from 2 to 7 90-degree turns. You can't have 2.5. It's either a 90-degree turn or it's not. So you can have 2, 3, 4, 5, 6, or 7. That's numerical. You can count those. But it would be discrete. You can't have half a turn. And then class standing. So freshman, sophomore, junior, senior. That's definitely, without a doubt, categorical. So that's number 1. That's just getting practice naming categorical and numerical variables. So now let's look at number 2. It says the paper profile of sport leisure injuries treated at emergency rooms at urban hospitals. Classified non-contact sports injuries by sport, and it resulted in the following table. Calculate the relative frequencies and then draw the corresponding bar chart. Okay. So remember, relative frequency, we have to add up the totals, and that category's count divided by the total gives you the relative frequency. So let's do that. What would our total be here? Well, I trust that you know how to add numbers. So if we add them all up, our total would be 178. So to get the relative frequency, we would say for touch football, it would be 38 divided by 178, which gets us 0.213. For soccer, it would be 24 divided by 178, which gets us 0.135. For basketball, it would be 19 divided by 178, and that gets us 0.107. And then you would just keep going down through each of these sports, getting their relative frequencies. So I'm not going to talk about each calculation. You do it the same way. You do the number divided by the total, and that gets you your relative frequency. So the next three would be 0.062. 17 would be 0.096, and then 47 is point. And then if you wanted to check to make sure you did this right, you can add them all up. Now, if we go through and add all of these up, we'll actually get that this is 1.001. Now, you may think, uh-oh, I didn't do something right, because I remember he told us relative frequency should add to 1. Well, it should, but we're off due to rounding error. So should be 1. But we're off due to rounding error. Okay. So we've done the relative frequencies. Now they ask us to draw the corresponding bar chart. Okay. So I am not the greatest artist. So I'm going to draw some axes in here, and then we'll go from there. Let me do this. Okay, insert shapes. Okay, there's us a set of axes. So let's see here. We're going to need our scale over here. So on this side, we're going to have relative frequency. I don't know why. I'm writing in red still. So over here, this is going to be relative frequency. Down below, this is going to be the sport. So remember your axis labels. And then our title up here will be non-contact sports injuries. Okay, now clearly, I'm not going to have room to write each of these out here. So I'm going to abbreviate them as follows. So touch football, I'm going to call TF. Soccer is going to be S. Basketball, I'm going to just say B. Baseball, softball, I'm going to say BS with a slash. Jogging / running, I'm going to say J/R. Bicycling, I'm going to call that bi because I already have B for basketball. Volleyball is V, and then other is going to be O. Okay, so if I look at my relative frequencies, I see that I'm going to need one to be all the way up at 0.264. So I want to do my scale accordingly. Maybe I want to count by fives. So let's see if I can do this evenly here. Fairly evenly at least. Okay, so let's see here. Let's say, gonna do. Uh, 10, 15. Let's see here. 5, 10, 15, 20, 25. Okay, so that's going to be as good as we're going to get here. So this is going to be 0.05 down here, 0.1, 0.15, 0.20, and 0.25. Now, yes, I know my highest is 0.26, which means I'll just be a smidgen above. No big deal. Okay, so now for my axes here. So touch football. We're going to put him right here. And we need to be at 0.213. So I'd say approximately right here. I'm going to try to draw a small rectangle right along here. Okay. Maybe make it a tad bit taller. I'd say that's good. And let's see, let's fill this. Let's just go that route. Oh, whoa, come on. Let's not get hasty now. Okay, so there's touch football. And then we're just going to keep doing this for soccer, basketball, etc. So this is going to be soccer. And soccer needs to be at 0.135. So instead of trying to draw a new rectangle, I'm just going to take this one, place it there, and shrink it. So I'd say about right there. And I'm going to go and draw my labels for the rest, so then I can just go boom, 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 done. So soccer. Basketball. Baseball, softball. You know what? Let's erase this. Let me do this instead. Hang on now. Bear with me. Okay, so I got the graph set up now. Now what we're going to do is go through and size the bars appropriately. So touch football we've already done. Soccer, we did that. Now let's do basketball. It needs to be at 0.107. So about right there. And then baseball, softball, jogging / running, and bicycling. Those are all going to be the same height, 0.062. So I'd say about right there. And then volleyball's 0.096. And then other is 0.264. So it's going to be our tallest. That looks good. Okay, so there is our graph. Took me a bit to get it set up, but it looks nice and neat now. So there's our graph, all done. So that's a bar chart with relative frequencies. Now, let's move on to number 3. the paper fire doors, a potential weak link in the protection chain, which was written in 1992, reported on a survey of companies that use fire doors to subdivide major plant facilities in case of uncontrollable fires. 4 types of doors were in use: rolling steel, which we're going to just call R, single metal clad sliding, which we're going to call M, swinging with door closer, which we're going to call C, and single swinging, which we're going to call S. Suppose the data were as shown in the following list. And the percentages that we'll find agree with those given in the paper. Just a little FYI. Determine the frequencies and relative frequencies of the 4 categories and display them in a relative frequency table. Then construct a bar chart for the data set and write a sentence or 2 commenting on interesting features. Okay, so this one has a lot going on here. Not only do we have to get frequencies and relative frequencies, we also have to go through and construct a bar chart and comment on the bar chart. So we've got a lot of work to do on this one. So let's, without further ado, let's get to work on that. First thing we want to do is get our table. So for our categories, those are just, we're just going to keep it simple. You can write out the full name of the door. I'm just going to use the letters they give us. So R, M, C, and S. R, M, C, and S. Those are our categories. Then we want to get frequency. So this is probably one of those things that will take up the most time because we've got to go through now and count each of them. So let's start with R's. We'll go through and count all the R's. Okay, so there should be 16 R's. Now let's do the M's. There's 15 M's. Then we need to get the C's. Okay, so there's 12 C's. And then the S's. 7 S's. Okay, so remember, to do relative frequency, we need to get the total number, figure out the total number, so that way we know what to divide by. So let's get our total down here. If I add all of these up, I'll end up with 50 doors. And then for relative frequency, we just divide the total, or divide the count by the total. So 16 divided by 50, 0.32. 15 divided by 50, 0.30. 12 divided by 50, 0.24. 7 divided by 50, 0.14. And if we go through and add all these up, we'll get our total is 0.1. So everything totaled out like it should. There's our table. Now we have to do a chart based on that table. So let me get our chart inserted into our document here. Okay, so I have a bare bones chart in here. So now let's make sure that we have all the pieces we need. So first we have our horizontal axis we need to deal with. This is the type of door. I don't want to be writing in red. So down here is our type of door. And we're just going to label our bars. R, M, C, and S. Okay. Our title would be Fire Doors at Plant Facilities. I mean, that's what this graph shows. And then we need our vertical axis. So looking at our table, our lowest is 0.14, the highest is 0.32. So we at least need to have tick marks that go up to 0.3. That's just bare minimum. So let's see what we can do here. So if we can count in increments of 0.05. So 5, 10, 15, 20, 25, 30, and then the top of our graph would be 35, which we don't need to go that high. So we're perfect. We're going to do, like I said, relative frequency here. So this is relative frequency. And we're counting by 0.05. Okay, so let's go through and adjust our bars accordingly. So R is 0.32. So we're going to need it to be about right there. M is 0.3 exactly. So about right there. C is 0.24. About right there, and then S is 0.14. I'd say about right there. And now make it a little bit bigger. There we go. I like how that looks. So there's our graph. But we're not done. But wait, there's more. Now we have to comment on any interesting features that we notice from our display. Well, in the future, we're going to talk about something called cussing the graph, but we haven't talked about that yet. So let's just look at our bar chart and see if there's any possible thing that's interesting that we could note. First thing is the most common, by far, or not by far, but the most common type of fire door is the rolling steel door. That's one thing we can notice. So I'm going to just down here say commentary, because that's what we're providing here. The most common type of fire door at the major plant facilities is the rolling steel door. And we denoted this with a capital R. The least common type of fire door at the plants is the single swinging door. And that's really the main two interesting things that or the two comments that we could say here. Now, I guess you could go further if you wanted to and say that it's the least common by, at least 10% is the single swinging door. I mean, you could get nitty gritty about it, but at this point, we could just say the most common is the rolling steel, least common, single swinging. I mean, that's that. I mean, you could say tons of other stuff. I mean, over twice as many plants have the rolling steel and the metal clad as these things. Anyways, I'm happy with just that. Telling me the most common, telling me the least common, and then just stopping. That would get you full credit because that's still some observations that you made. Okay, so there's number 3. Number 4. In a study of greeting cards, investigators categorize the cards according to the sex of the intended receiver and the dominant color in the card. A bar chart of the dominant color counts for both cards intended for males and cards intended for females is presented below. So let's look at these graphs and see if there's anything that we notice. Now, obviously, on my screen, you can see colors. If your review's one that I handed you in class, or actually it's in your packet, then they won't be in color, but I'm sorry, these colors kind of bother me because they don't match up with the words, but so be it. Anyways, they ask us, once we look at the graphs, to write a short paragraph describing the similarities and differences between the distributions of dominant colors for the two kinds of recipients. Okay, well, looking at them, let's see. What are some things that we notice that they have in common? Clearly, for both males and females, other is pretty darn popular. It's the one of the most popular colors. If we look at males, males probably aren't going to get a pink card. And females probably aren't getting brown cards. Then if you look at blue and tan, blue, males got blue about 27.5. That's our number there. So this is N stands for number of cards. So this is about 27.5 for blue. But if you look at blue for females, they're about 9.5. Somewhere in there. So it looks like all things being equal, as far as percentages go, males are 3 times as likely to get blue compared to females. Same thing with brown. They're way more likely to get brown than a female. They probably won't get white. Females tend to get the white. Yeah, so let's kind of put this into a paragraph. Now, since this is a paragraph, I'm just going to type it. I'm not going to handwrite it. But let's put our observations down here into a paragraph. So for both male and female, cards of other color seem to be the most popular, and that means not white, blue, mixed, tan, pink, green, or brown. That's what I mean by other color. As we said, it's very rare to see a card intended for a male. To be pink. Well, it's rare to see a brown card for a female. Also, a male is nearly 3 times as likely to get a blue or tan card as compared to a female. Okay, so there are some observations that we could write about these graphs. Notice they're not anything like eye-popping. They're just simple observations that can be made. That's it. Just simple observations that can be made here. I'm wanting to see, can you compare different cards here? Can you notice that these scales are different? So notice the different scales. Don't just go by looks. The scales are different. Okay, that's about all there is for number 4. We're just comparing. Okay, number 5. Collisions between birds and airplanes are a major problem, threatening passenger safety and resulting in costly repairs. During the years of 1990 to 1994, researchers gathered bird remains from runways at Lae Airport on the island of Kauai, Hawaii. Probably said that wrong, but anyways. The data below are counts of birds found on the runway used for takeoffs and the runway used for landings for the 4 most frequently involved species. So the species that we're using are zebra dove, mannequin sparrow, I'm guessing, plover, and barn owl. First, they ask us to construct a bar chart displaying the data for the takeoff runway. Takeoff runway. That's going to be this column that we do the bar chart on. Okay, so let me get at least a bare bones bar chart in here that we can use to create our chart that it asks us to create. Okay, so I got us a bare bones chart in here that we can work with. So got our axes, our bars, let's go. Okay, so now, of course, we have to have our essential elements. First thing, our axes. So down here, well, as long as you're not writing with a highlighter, you can put your axes in as horizontal would be species. And I'm going, for these, I'm going to use abbreviations, Z, M, P, and B. Because I don't have room. Okay, so there's our horizontal axis. It doesn't tell us what kind of bar chart to create. So let's just use flat out frequency. Let's not do relative frequency. Let's just do plain Jane frequency. We've done relative frequency already. Hopefully you kind of caught on how to do that. So for this one, I'm thinking we count by tens. What do you say? 10, 20, 30. So let's see here. 10, 20, 30, 40, 50. We don't need to go up to 60, but I'm going to put it for good measure. It can fit, so why not? Okay, so we're counting here by tens. Okay, so now we can do our bars. So for the zebra dove, it's all the way up at 49. So almost to 50. Mannequin sparrow is at 33. Plover is at 29. And then barn owl is at 6. So that's actually not going to be much taller. Okay, so there's our bar chart. Now, what are we missing? Yeah, title. So our title is Birds Found on Takeoff Runway. Okay, there's our bar chart. Now it asks us to construct a relative frequency distribution or table representing the bird species on the landing runway. So we're going to be dealing with landing here for part B. Now, what I recommend on one like this is to go on and just bring the species column down and the frequency column down. And then you have a relative frequency column. So species, let's see, we have the zebra dove. We got the mannequin sparrow. We have the plover. And we have the barn owl. Okay, and then the frequencies, they come just straight from the table above. So 68 for the zebra dove, 82 for the mannequin sparrow, 51, and 39. And then we need to do the relative frequency. Okay, so to do that, remember we need our totals down here. So what would our total be here? Add them up, you get 240. So for relative frequency, we would do 68 divided by 240. which would be 0.283. Then we do 82 divided by 240. That'd be 0.342. And then you just keep going. So 51 divided by 240. 0.213. And last but not least, 39 divided by 240 is 0.163. Now, ideally, you wouldn't show, if you're constructing a relative frequency table, you wouldn't show this part. So I'm going to make a note here. Don't show in table. These are the calculations you do, but I don't want it as part of the table. Hopefully that makes sense. To check your work, you can go through here and add everything up. It'd be 11. So it looks like we're off due to rounding error, but that's okay. So yeah, our official table would be just what I have in black. That would be the official table. The red is just how we went about and checked everything. So hopefully that makes sense. Okay, last question. Biologists know that bats have different flight characteristics. Some bats exhibit fast, straight, and long flights. Others are moderately slow and highly maneuverable. The flight capabilities of bats are presumably a function of A, the characteristics of their wings, and B, the laws of physics. The data presented below are wing weights in grams for certain species of bats from Nicaragua and Costa Rica. Two categories of bat species are represented: fruit eaters and insect eaters. And A asks us to construct 2 dot plots that will allow you to easily compare the distributions of the wing weights for the two categories of bats: fruit eaters and insect eaters. Okay, so let me insert a line here so that way we can have a number line to go on. And then I need to have the same line actually. I'm going to end up moving them both down. So when you do a comparative dot plot, actually on these, I don't want them with arrows. There we go. Okay. So when you do a comparative dot plot, you have a single heading here. So our heading is the, once I change my ink color, wing weights of bats. And then you break your lines into the two categories. So you have fruit eaters and you have your insect eaters. Now in each case, we're going to start at 0. And then if we look under the fruit eaters, how high does it go? 114 looks to be the highest. So even though insect eaters don't go as high, we need both of our lines to go all the way up to fit that 114 in there. So these are our weights. Wing weights down here. Okay, so let's see if we can figure out a scale here. That would be approximately equals. Okay, so here it's going to be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. 115 is going to be about right there. So this 110 tells me that I am easily long enough. I'll be able to fit 114 in because 114 would be about right there. That's going to be my biggest bat right there. Okay. So I need both lines to have the same scale. So before I even, yes, I know I just plotted 1 point, but I did that to make sure my line was big enough. So now I'm going to go to my second line and go on and put my tick marks in there. That way I can make sure they have the same exact scale. And the reason that we're doing this is to make sure that when we go to compare, it's easy to compare. The whole thing with stats is you don't want to be in a position where you can be accused of skewing the data, even though that's kind of what statisticians tend to do. If you want to be reputable, you can't skew your data, or they're not going to trust you. They're going to be like, what's he trying to do? So anyways, that's what we're trying to prevent. So go through and label. Now, if we really want to get particular, what are they? The wing weights are in grams. So we're going to put down, I'm going to put down in parentheses, this is in grams. Wing weights in grams. Okay. So now we go through for fruit eaters and we'll plot all of these points. So 9.9. Put it on the dot plot. It's pretty much 10, but not quite. 11.5. 47.0. 59.6. 18.2. 22.1. 22.9. 15.0. 15.4. 13.3. 38.3. 42.2. 114.3 is this one down here. 105.4. And then 80.9. Okay, so there's the fruit eaters. We've all plotted them. Now we need the insect eaters. So 23.8. 16.1. Actually, I don't like that. Let's move it a little bit further over. 4.2. 3.9. 7.5. 3.5 is going to be right here beside the 3.9. And then 3.9 again. Okay, so those are our comparative dot plots. Now notice we didn't have near as many insect eaters as we had fruit eaters, but we can't control that. We just plotted what they gave us. That's all we did. Plot what they give you. B asked us to write a short paragraph describing the features of the two plots. What do these plots tell you about the differences in wing weights for fruit and insect eaters? Okay, well, let's do our paragraph here. So since this is a paragraph, I'm just going to type it. I'm not going to try to handwrite it. So let's see, what can we say? First, notice your insect eaters. How do their wing weights compare to the fruit eaters? Just looking at the graph. They're closer together, okay? Do they go as high? No, not nearly. So insect eaters tend to have very low wing weights. And with that being said, although most fruit eaters have lower weights, just like our insect eaters, they have a larger variability. Of the weights. So they go from 9.9 all the way to 114.3. Then the insect eaters, which tend to go from 3.5 to 23.8. As we already mentioned, before we even read this question, there's also fewer observations for the insect eaters, meaning we only have 7 than for the fruit eaters, where we have 15 observations. So those are a couple of things that the dot plots can tell you. Okay, so that's it for the review. Yeah, that's it. I mean, study it, know it. Again, make sure you can do the vocab up here. Make sure you know your vocab. Yeah, that's it. Good luck.